This video will help you to understand how to locate the centroid of figures with cutout holes. The figure shows a composite section which consists of a triangle, a semicircle and a circular section. Okay, now in order to locate the centroid, the first step is to identify the reference axis, and normally we used to select a vertical axis passing through the left end of the figure as one of the reference axis, which is denoted by Y, and an axis passing through the base of the section as the second reference axis, which is denoted by X. Now from the figure we can see that the entire section lies in the first quadrant. Now when we try to find out the coordinates of any point lying on the first quadrant, it will be taken as positive. That is the main advantage of selecting the reference axis like this. Now after selecting the reference axis, the next step is to divide the composite section into symbol figures. So here we are going to divide this composite section into three symbol figures. The first one is taken as triangular section, second one is the semicircular section, and the third one is the circular section. We will be removing the circular section from the composite section. Now let's see how to locate the center of this composite section with respect to X and the Y axis. So before moving on to the solution, we will see how to find out the centroids of symbol figures such as triangle, semicircle and a circular section. So before solving the problem, let us see how to locate the centroid of symbol figures like triangle, circle and semicircle. The first one is triangle. The figure shows a triangle having a base B and height h. CG of the triangular section will be at a distance of b by 3 from the left end of the triangle and h by 3 from the base of the triangle, or it will be at a distance of 2h by 3 from the top of the triangle and 2b by 3 from the right end of the triangle. Now moving to the second one, that is circular section. So CG of the circular section will be exactly at the center of the circle, so which will be at a distance of r from the left end of the figure and r from the base of the circle. Now moving on to the third one, that is semicircle. So when we draw a vertical line passing through the center of the semicircle, we can see that the section is symmetrical about that vertical line, which means the CG will be at a distance of r from the left end of the figure and 4r by 3 pi from the flat end of the semicircular section, or it will be at a distance of r minus 4r by 3 pi from the curved end of the semicircular section. So this is all about the centroid of symbol figures. Now let's see how to locate the centroid of the shaded area given in figure. So G denotes the centroid of the composite section, which is at a distance of x bar from the y reference axis and y bar from the x axis. Now in order to find out the coordinates of this capital G, we need to find out the coordinates of CG of the triangular section, CG of the semicircular section and CG of the circular section with respect to the reference axis, and then using the formula x bar is equal to a1 x1 plus a2 x2 plus a3 x3 divided by a1 plus a2 plus a3, and y bar equal to a1 y1 plus a2 y2 plus a3 y3 divided by a1 plus a2 plus a3, we will be able to find out the values of x bar and y bar. Now in this equation, a1, a2 and a3 denotes the area of triangular section, semicircular section and circular section. Similarly, x1 denotes the distance of CG of the triangular section from the y-axis, x2 denotes the distance of CG of the semicircular section from the y-axis, and x3 denotes the distance of CG of the circular section from the y-axis. Similarly, y1, y2 and y3 denotes the distance of CGs of triangular section, semicircular section and circular section from the selected reference x-axis. Now in our case, since we are removing the third section, that is circular section from the composite section, we need to give a negative sign for a3. So our equation becomes x bar equal to a1 x1 plus a2 x2 minus a3 x3 divided by a1 plus a2 minus a3, and similarly y bar also will be a1 y1 plus a2 y2 minus a3 y3 divided by a1 plus a2 minus a3. So as I have told earlier, we will try to locate the centroid of the triangular section first with respect to our selected reference axis x and y. So for that, we will first remove the semicircular section and the circular section from the composite section. And we know that G1, what is G1? G1 is the centroid of the triangular section, right? So G1 will be at a distance of b by 3 from the left end of the figure, or with respect to the reference y-axis, and h by 3 from the base of the triangular section. But in our case, we need the distance G1 from the reference axis x. So we need to add the radius of the semicircle also to find out y1. So it will be rs plus h by 3. So triangle area will be half into base into h, y1 will be rs plus h by 3, and x1 will be b by 3. Okay, now coming to the semicircular section, we need to remove the triangular section as well as the circular section. So I am removing triangular section and circular section from the composite section. Now here you can see a semicircular section with two reference axes, and we know that G2 will be at a distance of rs from the left end of the figure or from the reference y-axis, and 4r by 3 pi from the flat end of the semicircular section. But here we need the distance from the reference axis, so it will be at a distance of radius minus 4r by 3 pi. That is, in our case, it will be rs minus 4rs by 3 pi. So area of the semicircular section will be pi r square by 2. Y2 will be r minus 4r by 3 pi, and x2 will be radius of the semicircular section. Now coming to circular section, we need to remove the triangular section and semicircular section in order to locate the centroid of the circular section. So before that, I am going to mark the center of the circular section. So it will be at a distance of rs from the x-axis and rs from the y-axis. So in order to locate the centroid of the circular section, I am going to remove the triangular section as well as the semicircular section. Then when we mark the centroid of the circular section, we can see that the centroid is also at a distance of 40 mm from the y and the x-axis. So area of the circle, that will be pi r square, and y3 will be equal to distance of CG from the x-axis, that is equal to 40 mm, and distance of CG from the reference y-axis, it will be x3, which is equal to 40 mm itself. So for convenience, I will be using a tabular format for finding out the centroid of the composite section with respect to the reference x and y axis. Now here in this table, we have 7 columns. The first column denotes the serial number, second column denotes the symbol figures, third one denotes the area of the symbol figures, then xi, which denotes the distance of CG of symbol figures from the reference y-axis. The next column is for ai xi, then yi, which denotes the distance of CG of the symbol figures from the reference x-axis, and the last column for ai yi. Then we will try to find out the sum of all the areas. Now since we know that we are removing the circular section, that will be marked as negative. So when you find the sum of all these areas, it will be a1 plus a2 minus a3. That will give the total sum of area of the symbol figures. Then similarly, you can find out the sum of these terms, that is a1x1 plus a2x2. Again, the third one will be minus a3x3 since area is negative. So similarly, you can find out the sum of these three figures also. Okay, now in order to locate or in order to find out the coordinates of CG, we will be using this formula. X bar is equal to sigma ai xi, that is this term divided by the total sum will give the distance of CG of the composite section from the y-axis, which will be 31.24 mm. Similarly, the final value divided by the total sum will give you the distance of CG of composite section from the x-axis, which will be equal to 41.54 mm. So these are the steps to be followed for finding out or for locating the centroid of the composite section with cutout holes.